And that allows this object to come very close to the inner planets. For example, it will come close to Mars, Venus, and Jupiter. And if you take the path of this object and just change randomly the arrival time, you find that there is a chance in 1 in 20,000.
In September 2025, the sky turned hostile. Asteroids slipped past Earth at distances measured not in millions of miles, but heartbeats. Days later, dozens more appeared, shattering every record. And as if chance was mocking us, a giant interstellar traveler, 3I Atlas, now races toward Mars. Its trajectory is so precise, so deliberate, that some wonder if it is mere coincidence. Wait until you hear why its precision has scientists divided. Growing threats and a visitor from beyond. The sky has become a stage filled with movement, and not all of it comes from familiar players. Over the past weeks, astronomers have watched the number of strange visitors climb, each discovery feeding a sense that something unusual is unfolding above. Yet at the center of all this attention sits one traveler unlike the rest.
Observing this rare comet that had water vapor in it.
An interstellar body known as 3I Atlas, rushing past the planets at remarkable speed. What might it reveal as it edges closer to Mars? That answer is coming. But first, the build-up around it deserves attention. In early September of 2025, alarms sounded across observatories. An asteroid labeled 2025. F-22 was confirmed at just over 2 lunar distances away, a margin of about 500 to 23,000 miles. Only days before, another named 2025 RJ2 had passed much nearer, barely 1 lunar distance away, or 187,000 miles. The second was tiny, only about 4 meters, while FA22 carried far more weight. Its estimated span ranged from 120 to nearly 300 meters, large enough to be classed as a potentially hazardous asteroid. Such alerts are no longer rare. The world's network of sky surveys has grown sharper, faster, and far more watchful. In Hawaii, the Pan-STARRS team monitors streams of raw data. Atlas runs from Chile. The Catalina survey in Arizona adds to the constant watch. High in Chile's Atacama Desert, the Rubin Observatory, only months into full operations, sweeps vast arcs of the heavens with its wide-field camera. Together, these eyes in the dark catch faint objects racing by, many logged within hours of their first detection. This surge of discoveries reflects more than luck. Advances in detection efficiency now exceed 90% for objects larger than 20 meters crossing within the orbit of the Moon.
And settle and be ready to take another image in 4 seconds. And that's very fast for a telescope.
Still, blind spots remain. Objects approaching from the sunward direction can appear without warning, just as they did 12 years ago during the Chelyabinsk event in Russia. What would happen if FA22, with its city block scale, had come any closer? Scientists ran the numbers. Entering the atmosphere at over 18 kilometers per second, a body of stony material that size could compress the air until it tore itself apart, releasing energy 1,000 times greater than Chelyabinsk and causing devastation across an entire region. Each new pass now sparks debate online. Social media posts trade orbital details, some worrying aloud, others marveling at the speed and distances involved. In research circles, the tone remains more focused. Every approach, whether harmless or hazardous, adds another layer to the growing defense system designed to protect Earth. Records are logged, models refined, and the collective database grows stronger. And still, while these smaller objects draw short bursts of attention, 3I Atlas continues on its own path. It is the third confirmed object to arrive from beyond our solar system, following Oumuamua in 2017 and Borisov in 2019.
It is only the third time we have detected an object that has come from beyond our solar system.
For over 2 months, scientists have tracked its every move, its velocity so high that escape from the sun's grip is certain. Now, as it closes on Mars, questions multiply. What secrets might be hidden in its strange chemistry? Could its path tell us about the space it came from? And most importantly, what else might be trailing behind it? The deadly power of Fa-22. Imagine the sky tearing open with a flash so bright that entire cities are thrown into chaos within seconds. That is the scale of danger tied to an asteroid like Fa-22. This massive object carries far more destructive energy than the Chelyabinsk meteor that once startled the world. Back in 2013 in Russia, that smaller rock detonated high above the ground. The shockwave alone shattered windows across 6 cities and sent more than 1,500 people to hospitals. Most of them were treated for cuts caused by flying glass and for concussions from the blast pressure. Yet, as frightening as that event was, Fa-22 holds over 20 times the energy. What would happen if something that large entered Earth's atmosphere? If made of stone, scientists explain it would most likely break apart at an altitude between 10 and 20 kilometers. But such a break would not lessen the threat. The sudden explosion in the sky would release energy measured in megatons of TNT. Buildings within dozens of square kilometers could be flattened. People would have only moments to react, and that is only if they even had any warning at all. The shock wave would sweep across neighborhoods with glass splintering in every direction. Rooftops would catch fire from the heat flash, and walls collapse inward.
A blinding flash of light, and then all hell broke loose.
The destruction would ripple far beyond the point of entry. Even those outside the direct blast zone could be struck by flying debris. In addition, they could also be crushed by structures that had lost their strength. The chaos of collapsing streets and burning roofs would magnify the danger, and the entire region would be scarred. What if Fa-22 is not made of stone at all, but of iron? The difference is critical. Iron asteroids are heavier, stronger, and far less likely to break up. Instead of fragmenting in the atmosphere, such a body could plow straight through and hit the surface almost intact. The outcome would be catastrophic. A crater hundreds of meters wide would scar the land. A fireball blazing across the sky would be seen for miles. Dust, ash, and rock blasted high into the stratosphere would rain back down. The local impact alone would devastate infrastructure, wiping out everything within reach. But scientists warn the consequences might not end there. Depending on where it landed, the plume of dust and debris could drift across continents. This would dim sunlight and alter climate on a regional or even global scale. Oceans as impact zones. The ocean may look calm on the surface, but when a celestial object slams into it, everything changes in an instant. More than 2/3 of potential asteroid impact sites are in the sea, which means the first thing unleashed is a plume that rises high into the atmosphere. What follows is even more unsettling: a series of tsunamis radiating outwards. In deep waters, most of the energy quickly spreads and weakens, but when those waves approach land, the story shifts. Coastal regions within a few hundred kilometers could face towering walls of water, some tens of meters high. Researchers studying the scenario of a 200-meter asteroid found that waves near the impact site could range anywhere from 10 to 50 meters. That is the height of a multi-story building crashing down without mercy. What would happen to crowded ports, cities pressed against the shoreline, or low-lying islands? The truth is simple. Many of them would be underwater before an evacuation could even begin. Entire neighborhoods could vanish beneath the waves, with little to no time for escape. But the danger does not end at water. The Chelyabinsk event in Russia showed the world how vulnerable we really are. That meteor slipped in from the direction of the sun.
The Chelyabinsk meteor exploded in a spectacular fashion over Russia on February 15, 2013.
Completely hidden from Earth's telescopes until the moment it exploded in the atmosphere. Ground-based systems, even in the year 2025, still cannot spot threats that come from that angle. The result is a blind spot that leaves millions of people exposed. So what can be done? Experts point to space-based infrared telescopes like the planned NEO Surveyor, which is expected to launch around 2028. Positioned beyond Earth's atmosphere, it would be able to detect objects approaching from the sun's glare. Without such technology, humanity remains one step behind, watching the skies but missing what hides in the light. Every simulation carried out after close encounters delivers the same sobering message. The impact energy, the number of people in harm's way, even the time of day. These are pieces of a cosmic equation with no emotion or intent. The only real defense is to see the threat early and prepare before it arrives. Because if detection fails, the outcome is measured not in statistics, but in ruined cities and lives torn apart. Swan. Now, let us turn to another discovery that caught scientists by surprise, one that began not in deep space, but in the very direction of the sun itself. On September 11, 2025, instruments aboard the Solar and Heliospheric Observatory, specifically the SWAN detector, revealed the presence of a new comet.
Newsfeed now talking about comet Swan tail brushing past Earth, sending a debris field into our atmosphere.
It was given the name C2025R2, or more simply, SWAN. What immediately drew attention was its brightness and the long tail stretching across 2 full degrees in the sky. Amateur astronomers managed to spot it near the sun, though the timing made things complicated. From early August until mid-September, it had been traveling within 30 degrees of the sun from Earth's perspective. That position meant most ground-based telescopes were unable to see it until the spacecraft data made its presence clear. Its closest approach to the sun, known as perihelion, took place on September 12th. At that point, it was just 75 million kilometers away.
In early September, an amateur astronomer noticed something unusual in solar observation data, a faint smudge moving through space.
About half the distance between the Earth and the sun. The orbital path it follows is far from ordinary daily cycles. It will not return for nearly 3 centuries, since its journey around the sun lasts 286 years. At its farthest, the comet drifts out to 86 astronomical units, reaching into the outer regions of the Kuiper Belt. The next concern was its intersection with Earth's orbit. On October 5th, our planet would cross through the track left behind by SWAN, raising the possibility of a meteor shower. Then, on October 20th, the comet itself would make its nearest pass by Earth at a distance of 39 million kilometers. That may sound vast, but in cosmic terms, it was close enough to warrant intense observation. Yet brightness and trajectory were only part of the story. Spectroscopic data uncovered something unusual. Instead of a coma dominated by water vapor, as is common with comets, SWAN displayed a rich mix of hydrogen along with traces of cyanogen and carbon compounds. As it moved toward perihelion, the rate of hydrogen release rose sharply, surpassing expectations. Researchers soon realized the cause. The comet's icy nucleus was undergoing fragmentation, its surface cracking under the relentless heat of the sun. Each fracture exposed new layers, releasing hidden volatiles in violent bursts. Instruments tuned to ultraviolet wavelengths recorded these hydrogen outbursts with remarkable clarity. Professional observatories raced to gather as much data as possible. The Rubin Observatory adjusted its schedule to monitor changes in the coma, while high-resolution spectrographs tracked shifts in the chemical blend. Jets of gas were seen shooting outward, altering the shape of the tail, and subtle patterns suggested the nucleus was under severe stress. At the same time, citizen scientists around the globe became critical contributors. With their own equipment, they timed eruptions, mapped the evolving tail, and flagged sudden variations in brightness. Their reports often reached research centers within hours. This allowed professionals to focus their instruments on moments that might otherwise have been missed. As September advanced, the possibility of a complete breakup became a growing question. Could the nucleus hold together, or would it shatter near the Sun, models indicated that collapse was a real risk. If that happened, the fragments could form a debris cloud that might be visible from Earth. For astronomers, this was a scientific opportunity.
Amateur astronomer Vladimir Bazugli is just looking at data from SOHO, which is the solar observatory out in space that studies the Sun.
For planetary defense experts, it was a sobering lesson. Objects like SWAN do not always behave in steady, predictable ways. Sometimes the warning signs come as sudden surges of gas, and the first to notice are often not satellites or large observatories, but ordinary people scattered across the world with their eyes fixed on the night sky. The threat of 2024. Among the many objects catalogued, this next one forced experts to consider the worst. In late 2024, a near-Earth asteroid was picked up by the Atlas telescope in Rio Hurtado, Chile.
NASA-funded Atlas survey. It was discovered using their telescope at Rio Hurtado in Chile.
It was later recovered in archived data from the Catalina Sky Survey, which confirmed its presence. The asteroid was given the designation 2024 YR4, and its size was estimated at about 196 feet across, roughly half the length of a football field. Though that measurement seemed small compared to larger space rocks, the real issue was its trajectory. Projections showed that on December 22, 2032, the asteroid would come extremely close to Earth. The distance was estimated at around 66,000 miles, a margin much smaller than the space separating our planet from the Moon. For comparison, most satellites orbit closer than that. The possibility that the orbit might shift into a collision course could not be ignored. Some scientists calculated that even a slight adjustment in its path might result in the asteroid entering Earth's atmosphere. What would that mean if it happened? If the asteroid burned up in the sky, the result could be a violent airburst. But if it survived passage through the atmosphere and struck the ground, it could carve out a crater and release energy equal to multiple nuclear explosions. This was why it immediately moved to the top of both NASA's Sentry Risk Table and the European Space Agency's Impact Risk List. The Torino scale, which measures the hazard of near-Earth objects, ranked it at level 3. That indicated more than a 1% chance of collision, high enough to demand constant monitoring. Such a rating was rare and left many wondering just how much of a threat this asteroid truly posed. Could the calculations be right? Or was it a case where the numbers might change with new observations? 6 megatons against the Moon. Now the attention shifted in a surprising direction, and the threat no longer seemed centered on Earth alone. Fresh calculations eased immediate fears, showing that 2024 YR4 would not collide with our planet. Yet relief quickly gave way to a different kind of concern. Astronomers realized the asteroid's orbit could place the Moon directly in its path.
The asteroid has a 4% chance of hitting the Moon.
That possibility raised unsettling questions. What would happen if a rock nearly 200 feet wide slammed into the lunar surface? The answer painted a troubling picture. Scientists at the University of Western Ontario estimated that such an impact would release energy equal to 6.5 megatons of TNT. To put that into perspective, the atomic bomb dropped on Hiroshima during the Second World War released just a fraction of that amount. The sheer force of the blast could create a crater miles deep on the Moon's surface. But the larger problem lay in the aftermath. A collision of that scale would throw up a massive cloud of debris. Those fragments would not stay neatly around the Moon. Instead, many of them could be pulled toward Earth. This would threaten satellites that orbit the planet and even the astronauts working aboard the International Space Station.
Our new data suggests the planet is cleared from impact, but there are risks to satellites.
The risk extended further, since spacecraft scattered across different orbits could also be affected, which would disable vital systems and cut off communication links. Could humanity afford to face such a chain reaction in space? Faced with those scenarios, researchers began to consider extreme options. One proposal suggested that nuclear technology could be used against the asteroid. The proposal, citing NASA experts, spoke of nuclear robust disruption missions that might be deployed sometime between 2029 and 2031. The idea was simple but drastic. Intercept the asteroid before it reached the Moon and shatter it into smaller, less threatening pieces. This suggestion sparked debates among specialists. Would the use of nuclear weapons in space create new risks? Or was it the only practical defense against such a destructive outcome? The clock is ticking, and while there is time before any possible encounter, the weight of the decision hangs over those tasked with protecting not only Earth, but also the fragile balance of its cosmic neighbor. The day Apophis passes close. April the 13th, 2029, is a date that sits like a shadow on the calendar of planetary defense. On that day, Apophis will slip closer to Earth than many satellites circling above. It will pass at a distance of just 20,000 miles. Apophis was first detected in 2004, quickly earning a reputation as a potential planet killer. Headlines spoke of doom, sparking fears of an unavoidable collision. Yet over the years, careful tracking erased those fears. The asteroid will not strike Earth during this approach, but the danger has not been replaced with relief alone. Instead, scientists now see a chance to gather information they could never create inside a laboratory. Could this close encounter become the most important rehearsal in planetary defense? When Apophis swings by, the pull of Earth's gravity will not leave it untouched. The encounter will stretch, twist, and squeeze the asteroid in ways rarely witnessed. Its orbit around the Sun will change, becoming slightly larger, and lengthening the time it takes to circle once more. Its spin might quicken or slow, shifting its orientation in space. Even the surface of the asteroid may not remain still. Slopes already near collapse could give way, causing small landslides or sending loose rocks drifting into space. Why does this matter? Because the way Apophis reacts to these forces will reveal what lies beneath its surface. If the asteroid holds together tightly like solid stone, the changes may be small. But if it is more like a loose pile of rubble barely clinging together, the effects could be far more dramatic. Every observation, every shift in motion becomes a clue to its hidden makeup. Scientists believe that by measuring these disturbances, they can work backwards to unlock secrets of its internal structure. And that is where the importance deepens. Apophis has its roots in the earliest days of the solar system. It is made from leftover material that never became part of any planet or moon. This means studying it offers a direct look back to the raw beginnings of everything we know. Can a close brush with a so-called planet killer teach us more about our own origins? The encounter, visible across parts of the globe, will be unlike anything seen before. Millions of eyes will follow it as telescopes track its every move and instruments record data. For once, humanity has the chance to prepare, to test, and to learn before facing a real impact threat. The race to study Apophis. The countdown is already underway, and scientists know that what comes next could change our understanding of asteroids forever. Apophis, classified as an S-type asteroid, is composed of silicate-rich rock along with metallic nickel and iron. Radar images already suggest that its shape is elongated, perhaps even split into two connected lobes. But how stable is it? And what secrets could its internal makeup hold once it passes so close to Earth? Although experts agree it poses no immediate danger, its close approach in 2029 is anything but ordinary. Asteroids of this size do not brush past our planet at such a distance very often. In fact, such an encounter happens only once every few thousand years. That means humanity has never before recorded such an event with the instruments and technology we have today. For researchers, this is a chance that might not come again for many lifetimes. Several missions are already lined up to seize the moment. One of them is Ramses, which is scheduled for launch in the spring of 2028. Its goal is ambitious: to study Apophis in extraordinary detail. It will track changes in its orbit, analyze its rotation, probe its internal structure, and measure how Earth's gravity reshapes its surface during the encounter. Every shift and crack could tell us something new about how these space rocks behave. NASA, too, is preparing. The OSIRIS-PEX spacecraft, an extended mission of the agency's earlier Bennu project, is already on course for Apophis. After traveling millions of kilometers, it will be ready to watch the asteroid's dramatic passage unfold. This event is not just about Apophis. It is about learning how asteroids respond when pulled by a planet's gravity and testing the limits of our ability to study them up close. The lessons from 2029 may become the foundation for future planetary defense strategies. What scientists see and measure in that moment could decide how we prepare for the day when an asteroid does not simply pass us by. The comet that defies expectations. Few expected that a comet flying in from deep space would trigger so much debate. Yet 3I Atlas has done exactly that. Racing through the solar system at an incredible 137,000 miles per hour, it has become the center of scientific attention.
NASA scientists first spotting 3I Atlas in July, just a tiny speck of light sailing through a sea of stars.
Then came something no one saw coming. The sun hurled a coronal mass ejection straight toward it. What effect would that blast of charged particles have on such a fragile visitor? Could it strip away surface layers, or would it reveal something hidden within? Ever since it was first detected, on the 1st of July 2025 by the Asteroid Terrestrial Impact Last Alert System in Chile, astronomers have been keeping their eyes fixed on it, and the closer they looked, the stranger it became.
NASA-funded telescopes have their eyes on the sky all the time, and first spotted this object back in July.
Instead of following the usual chemical pattern seen in most comets, its composition turned those expectations upside down. In August 2025, researchers confirmed that its carbon dioxide production was measured at 129 kilograms per second, while water trailed far behind at just 6.6. That is a ratio of nearly 20 to 1. For a comet shining so brightly and releasing gas so actively.
But 3I Atlas is behaving very differently, even with these gas clouds forming around it.
This was unheard of. Normally, water dominates and carbon dioxide comes in far lower. Here, the usual order was flipped entirely. But the surprises did not end there. Night after night in July and August, high-resolution spectra from the Very Large Telescope in Chile revealed a sharp nickel signal pouring out of the comet's coma at 4.6 grams per second. What startled researchers most was not what they found, but what they did not. Iron, a constant partner of nickel in cometary material, was missing, registering below the detection threshold. How could a comet shed nickel while leaving iron behind? Ideas quickly began to surface. Some argued that 3I Atlas must have formed under conditions unlike anything seen in the solar system. Others suggested that during its long journey between the stars, iron compounds may have been stripped away by radiation or lost through chemical changes, while nickel endured. A few even pointed to complex organic materials that may break down to release nickel, but not iron. None of these explanations fully solve the mystery. That has left the scientific community in lively debate, with each observation raising more questions than it answers. 3I Atlas and the precision of its path. It is one thing to study a comet racing through space, but it is another when its path takes it unsettlingly close to the orbits of the inner planet's planets.
It's partially due to the size of the object, but also it's partially due to the activity, and so we cannot really pinpoint.
3I Atlas, despite its unusual journey, carries no threat to Earth. Yet its trajectory has been so precise that by October 2025, it will pass within 1.67 million miles of Mars' orbit. One astronomer described this as a remarkable fine-tuning of its path.
In the case of 3I Atlas, as soon as it was discovered, 20 kilometers, which is huge.
And it has fueled both excitement and speculation. Could such accuracy really be a coincidence, or is there something more deliberate behind it? Some have gone as far as to suggest that 3I Atlas may not be just a natural body. A fringe group of researchers floated the idea that it could be a technological artifact.
It's easier for me to think this is a new kind of object.
Just been discovered. 3I Atlas was discovered on July 1st.
Possibly even an instrument designed by intelligent beings. They argue that its repeated brushes with Venus, Mars, and Jupiter could be purposeful, a way of gathering astrometric data on planetary orbits and masses. To them, the tilt and trajectory look like choices rather than chance. But is that stretching the imagination too far? NASA has strongly dismissed those claims. To their scientists, the evidence still points toward a natural interstellar comet. Still, the object's sheer scale adds to the puzzle. With a mass estimated at more than 33 billion tons and a diameter of at least 3.1 miles, it is not something easily ignored. Few visitors from beyond the solar system have ever matched its size. As it moves toward perihelion, its closest approach to the Sun, astronomers have noticed something else. The comet has grown brighter, not in a steady glow, but in sudden surges that have transformed its appearance. Much of this brightening has been observed in the green part of the visible spectrum. The cause, according to specialists at Space Weather, is diatomic carbon. When bombarded by ultraviolet radiation from the Sun, this compound gives off a striking emerald hue. That glow has become the comet's signature, visible proof of the violent chemical reactions taking place as solar energy breaks apart material within its nucleus. For astronomers, these observations are not just visual spectacles. Each change in brightness tells them more about the structure, makeup, and behavior of a body forged in another star system. And as they continue to track its progress, one question remains unsettled. Will the mysteries of 3I Atlas unravel under the Sun's heat, or will they remain locked within, carried back into the cold silence of deep space? If you enjoyed this breakdown of one of the most mysterious visitors in our skies, don't forget to like the video and subscribe to the channel. That way, you won't miss the next story. Thank you for watching. See you in the next video.